The term application from the lecture title Currying and Partial Function Application simply means calling a function. In other words, when you call a function, say add, with some arguments, you apply it to the two arguments, 3 and 4 in this example. In some cases, it can be useful to not provide all arguments immediately, but only some of them. This process of decreasing the arity is called partial application. If we bind the first parameter of add to 3, we get a function with a different signature in our type notation. How would this look like in C++? What could this be good for, you ask? Let's say you have a sequence of integers and want to add 3 to all of them. This is where add3 comes into play. Writing out such a function, even as a lambda, sadly is not very elegant. But we can bind a parameter in a more concise way, so we do not need to create a helper function on our own. Also, we could design our add function from the beginning on in a way that makes this process easier. So add now does not take 2 arguments, but only 1, and then returns a function that takes another argument. Now we could call it like that. This process is called currying, named after the mathematician Haskell Curry. The type signature of add curried looks like this. Since the arrow in this notation is right associative, this is equivalent to that. Some functional programming languages like Haskell, F# and Elm have all functions curried by default. In these languages, every function actually only takes one parameter and returns either a value or another function that again takes only one parameter. Currying can be done for an arbitrary number of parameters. C++ does not use currying by default, but as you see in the transform add3 example, it can be handy from time to time. Now, say you have a nested sequence and you only want to keep the even values of the inner sequences. You now need to transform the sequence with keepIf is even. But the type signature of keepIf is the following. So we need a curried version to be able to do this. You now have the following options. You can bind the first parameter of keepIf with bind first of 2. Or you can create the closure on your own with a lambda expression. But there is a third, even better option. In the namespace forward, written as fwd, you find many functional plus functions in a partially curried way. They take all but the last parameter in a normal way and then return a unary function taking the last parameter. You can also see those on the API search website. So, currying has helped us to make our code nice and short. Now it's your turn. As an exercise, square every inner value of XSS. Try out different possibilities to achieve your goal.